I'm Maren Hunsberger. I'm a science and tech communicator, and that means that I get to talk to really smart people about what they do. So today I'm here with Daniel Hume. He's the founder and CEO of Satalia, the chief AI officer at WPP, and now the co-founder and CEO of Conscium, the world's first commercial research organization investigating the implications of building machine consciousness. So Daniel, today I want to ask you, what is the high-level focus of Conscium?
Conscium's leaning into two very big questions that I think that we are facing as a species. The first question is, can we align intelligent machines? And I guess there are two big questions in that respect. One is, can you control intelligent machines? And there's one school of thought where we can't actually control intelligent machines. But there is a question of, can we align an intelligent machine or a super intelligent machine with some sort of moral system? So the first question is can we align in ever more intelligent machines with some sort of moral system? And the second question is going to sound science fictional, but it was coined by a science philosopher called Nick Bostrom, called mindcrime, which is, if we are building machines that have become more and more intelligent, it might be that we end up building machines that are conscious and not realizing it, and that we could put them in difficult, torturous, tormented situations. And we have a duty of care not just to human beings and to animals, but we also have a duty of care to AIs. So Conscium is trying to solve two things. One, building AIs that are safe for humans, but also building AIs that are safe for AIs.
Wow. So we're talking about a post-technological singularity world.
Well, not necessarily. I think that there are different levels of consciousness. There are insect, animal level consciousness, human level consciousness, potentially a super level consciousness. But there are some new emerging technologies that are now starting to commercialize from academia that are predicated much more on how our brains work. They're called neuromorphic technologies. Large language models are very energy inefficient. They take lots of data to learn, to train. They're not very adaptable. Our brains operate on the power of a light bulb, and we learn and adapt very, very quickly. Neuromorphic technologies are more complex types of neural networks, but they are incredibly energy efficient, and they adapt very quickly. So what I think will happen is that these technologies are going to start to emerge more and more over the coming several years, and they are going to be embedded in drones, in robots, in devices that interact with us in the real world. Now, it's possible that those devices could start to recognize its propeller or its arm or itself in the mirror. It's possible that those devices have intent, that they have the ability to measure their own kind of energy levels and health levels. And if, for example, they can't achieve their intent, could they, for example, feel anxiety? And so these new neuromorphic technologies are essentially going to spawn insect, animal type brains, and we need to make sure that they're safe for humans and also safe for themselves.
And how does one measure how advanced a consciousness might be within a machine?
Well, there are three pillars within Conscium. The first pillar is, first of all, defining what consciousness is, and we've managed to attract the world's leading thinkers that are now backing Conscium, who've been experts in consciousness for many, many decades. Mark Solms, Carl Friston, Anil Seth, many world leading thinkers. And what they're helping us do is to understand the kind of different types of consciousness. There isn't really one definition of consciousness. There's, can you feel? Are you aware of yourself? Can you do kind of metacognition? Can you do complex planning? There are different types of things that we might attribute to be consciousness that people try to collapse into a single definition. So the first thing is understanding what the sort of landscape of consciousness is, and then what are the behavioral markers that we might want to look for to determine whether something is conscious. We also want to understand what are the behavioral markers associated with whether something feels anxiety or pain or fear or any type of emotion, and that's not looking kind of just externally at the agent, but also potentially looking at brain scans, so what's going on inside the brain of that agent, and to understand how it thinks and feels. But also we want to test for moral behaviors as well. So the first pillar is really understanding what are the behavioral markers for consciousness, what are the behavioral markers for feeling, for emotion, for suffering, and what are the behavioral markers for some sort of moral system. The second pillar is the platforms, the tools, the picks and shovels to enable people to be able to build these agents, these neuromorphic agents. Now, we think that that's a massively commercial opportunity where people will be able to build now tools and brains that are going to be powering drones and other things. But we are also going to be using that tool set, that platform to evolve agents in environments to try to embed moral behaviors. I'll say that again because it's very important. I can create an environment where AIs have to sort of kill and fight each other and lie and cheat to survive. Or I can create an environment where to survive you have to cooperate or be altruistic or sacrificial. And what you can do is you can essentially create environments where you can embed morality or moral behaviors within agents, because otherwise they wouldn't have survived. So if I've got a drone flying around this room, I would want to know, for example, that if I'm about to fall off my chair, will the drone sacrifice itself to save me? So the second pillar is us using these tools and technologies to embed morality or moral systems in these agents, but also making them available for everybody to build neuromorphic agents. And the third pillar are, what are the tests that we need to be able to determine whether an AI is safe or conscious or aligned with some sort of moral system? So, for example, there's a concept called the mirror test, which is, can you recognize yourself in a mirror? And the way of running that test is you put some dirty mark on your head, you show yourself in a mirror, and you do this instead of doing this to the mirror. And apparently there are 8 species of animal, for example, that are able to recognize themselves in the mirror. So what we'd be wanting to do is identifying all of these different tests to be able to determine consciousness, to be able to determine suffering, or to be able to determine some sort of moral leaning. And one way of getting these tests is that we are about to launch an app called Moral Me. Moral Me is an app that allows people to submit moral dilemmas. So any moral dilemma might be the trolley problem. The trolley problem is I've got a trolley moving towards 5 people that are tied to a track. Do I pull the lever and kill one person, or do I kill the 5 people? This is a moral question. A moral question might be, should I have ice in my water or not? This is a moral question. There are lots and lots of moral questions that we could crowdsource. We then get human beings to answer those moral questions, and we are then able to then profile people based on their kind of their answers to these questions. And you'll answer these questions based on your demographics and your religious beliefs and all that kind of stuff. And there's a well-established framework called moral foundation theory that allows you to profile people sort of morally. What we can do is we can then use those tests that we're collecting in Moral Me to be able to test AIs against. So I'll be able to now start to use these tests to profile the moral leanings of AI agents.
So when you're using Moral Me in the development of these AI agents, is that because you want to see if a particular AI agent has developed a particular moral framework that aligns with one of these real human bases? What happens to the AI agents that get created that maybe aren't morally aligned with us?
Well, first of all, we want to be the place where anybody that creates any agent, whether they are large language models or neuromorphic agents, we want to be the place where they can submit their agents and verify that those agents are, first of all, not conscious, not going to suffer, but also can verify that moral framework. So it's a way of understanding how to define a moral framework for your AI. Now, you might say, well, that moral framework is not how I want that AI to operate. What do I need to do to change the morality of that AI? So one of the things that we're trying to understand is, how does your environment embed moral leanings? So you give me an agent that has a certain moral profile, but you want to change its moral profile slightly. We'd be able to help you understand how to run that environment, to train that environment, teach that environment other things to be able to change its moral profile.
As a biologist, a lot of these things are sounding very familiar. The training the AI within an environment that it encourages or incentivizes or selects for certain behaviors sounds a lot like natural selection, or in this case, selective breeding, essentially.
It's exactly evolutionary theory. So I guess what's happening at the moment is that people are building large language models, very big brains, and they're playing kind of whack-a-mole to try to make sure that these brains are not doing anything bad, which I think is a very silly and dangerous thing to do. What our approach is going to be evolving very simple agents in environments, and your natural selection will hopefully select agents that have the behavior that we want to embed.
Wow. And then when it comes to their own consciousness and making sure that we are treating AI agents themselves in an ethical way, the mirror test obviously involves a visual. What's a version of a mirror test for an AI agent?
Well, so I guess what's happening at the moment is large language models are trained on a corpus of text. And what's interesting about that is that they've been able to somehow generate a world model. That's not really how biology has evolved. Originally we would have probably tentacles. We'd be touching our environment, trying to understand objects and textures and physics. We then had eyes, which allowed us to kind of validate that environment. We then had sound, which we were able to then connect. We had then words, and then we were able to turn those words into language. So we've gone from a world model, understanding physics, to language rather than from language down, and so that's our approach to developing these agents. And so in a world where we have robots that are operating around us, it's likely that those are not going to be powered by large language models. They're not actually going to understand language, but they are going to understand physics and the world and have this world model. So we want to be able to run moral dilemmas, not just using language, but we want to be able to run agents in simulated scenarios, like me leaning back on my chair, to see how they will behave in those types of situations.
I see. And then when it comes to measuring whether or not they have a sense of self, how does that work?
Well, so that's down to us, identifying these behavioral markers for consciousness and running the appropriate tests. I actually think we're still a way away from developing agents that might have, consciousness, aspects of consciousness. I'm just more interested initially on trying to embed moral behaviors and trying to make sure that these agents are useful for the world and not causing harm. But I do think that as agents start to recognize self, start to recognize and see themselves and feel themselves, then we might end up having this concept of sentience and self-awareness, which I think we need to mitigate or identify before it happens. I think one of my worries is that we might end up having machines that are conscious before we even define consciousness. And as I said, we have a duty of care not just to human beings and animals, but we also have a duty of care to AIs.
Absolutely. Do you guys have a sense at Conscium what those behavioral markers would be for selfhood and for consciousness?
Well, fortunately, I say we managed to attract the world's leading advisory board on this subject. So they've spent decades identifying behavioral markers in animals, in humans, including brain scans that we're going to be leveraging and building upon.
Wow, so you can adapt a lot of those biological tools that we've used to assess living beings, and you can apply them to something like a neuromorphic brain.
Exactly, and that's the key word, is neuromorph, because it wouldn't really allow you to understand how large language models work, because they are a long way away from our brains work. Neuromorphic technologies tend to use what are called spiking neural networks. Our brains don't propagate numbers. They propagate spikes of different frequencies and
electrical signal and neurochemicals.
Exactly, and you have to then process spikes over a temporal period. And so what we're expected to start to see are parallels in terms of how our spiking neural networks, our brains work, and then how artificial spiking neural networks work, and then draw parallels between those two systems. What's also very exciting about the idea of spiking neural networks is not only are they incredibly energy efficient and more biologically aligned, but they're also explainable. It's very hard to look inside a large language model and explain how it's thinking, how it's learning. With spiking neural networks, neuromorphic technologies, they're going to be much more explainable and also obviously more safer.
That's interesting to me because, in science, we often talk about how we know more about space than we know about the brain. There's so much that we still don't know about the brain. So how is it that a neuromorphic computing network could be explainable in that way?
Well, so you're starting to see now studies that are showing when MRI scans of people's brains, and they're able to kind of recreate what it is that people are thinking. So essentially, we'll be able to look at the activation of neurons and say, well, we think that it's thinking or feeling this, which is why not just looking at external behaviors to try to attribute consciousness, but actually looking at internal states, i.e. brain activity, will also help you understand whether something's suffering or anxious or conscious.
Absolutely. I can sort of picture in my mind, this classic stock image of like an electrical signal passing through a brain representing this neuromorphic computing network. But in reality, what kind of machine are we talking about that this neuromorphic network would live on?
Well, neuromorphic technologies have been developed for the past several decades, and there are two components. One is a software component, how are brains learning, how do they process information, which is the spikes, and then there's the hardware that those brains run on. So traditional GPUs, CPUs are not necessarily very good at processing spikes. There's a lot of research now that's happening around this area, but there has been decades of research and investment in building neuromorphic chips. Now, we also think you can't just just have a brain, you need to have embodiment. So you need to have things that can sense the world and that can get feedback from the world. So again, this is why we think that these brains are right for spawning the robotic revolution.
Sure, because they will be out interacting with their sensory environment.
Yep.
That's so interesting. So this is not just a major advance in computing capability, but also in the hardware and the software that accompany it and all of that infrastructure that surrounds it.
Yeah, indeed. And so the idea is we're going to bring together all of those technologies, those open source tools that we're developing ourselves, as well as getting access to the hardware and making it available as a platform. So we're going to be enabling people to build their own neuromorphic agents, to be able to test those neuromorphic agents against these verification methodologies. They'll be able to bring their own agents in and test them. We'll be able to build agents for them. So let's say you're a company that wants to, build drone brains that are able to go and forage for, I don't know, for some sort of resource. We'd be able to have some brains that are sort of ready-made that can be then tuned for solving that problem. So the commercial opportunity here are three things. One is making these technologies available for people as a platform. The second is us building agents and safe neuromorphic brains for organizations and being able to make sure that they're verified. And then the third commercial opportunity is actually Moral Me. So that we think that this app, Moral Me, has the opportunity not just to be able to provide the tests for AIs, but we think we can then actually start to build AIs that could potentially become a moral advisor. How could you get an agent to help you work through some of your moral dilemmas? We could even build agents that could help create safe, facilitated discussions online. I think the argument is that a lot of social media platforms are places where people are polarized, are arguing, or fighting, not necessarily in the most rational way. So could you use AIs that have a sense of an understanding of human morality and argument and biases to be able to actually facilitate safe dialogue to allow people to get to better conclusions?
Wow. And so Moral Me as an app is both feeding into this environment that could be used to train AI agents, but is also maybe feeding back to the user that knowledge of, okay, here's the data that we've acquired and here's how it could be applied to these different situations.
Yeah, you've absolutely got it. So it's there are two directions. One is understanding humans and human morality and psychology that can help us be able to profile AIs, but it also can help humans elevate their own understanding of themselves.
Wow. Will it be available just to organizations that are interested in this field or to anyone who might want to use it?
It's going to be available to everybody. We're going to be launching very soon. There'll be a freemium version and then there'll be a premium version where you'll be able to compare your moral or psychological profile to Gandhi or anything like this. And again, obviously, we're going to make sure that data is being used safely and responsibly.
Wow. What data is it drawing on now?
So at the moment, we are collecting data in terms of how people answer their questions, but we are also collecting demographic data where we're allowed to, because we think that obviously there are differences in terms of how people approach these questions based on their age, their religious beliefs, their demographics, and actually understanding the delta, understanding the difference between how one type of demographic thinks versus another is actually quite a powerful data source, again, that we'll be engaging with academia in and making that data available for them to do more research.
Yeah, seems like it would be applicable to any industry or area that I could possibly think of in terms of media, communications, education, product marketing.
Well, there's a reason why WPP has invested in Conscium, which is we think that the data can also help us understand audiences better, and making sure that we're building safe and more representative and useful content for people.
That makes sense.
Yeah, I mean, also we're really interested in building agents that solve problems across our marketing supply chain, and one of the thoughts is that these neuromorphic agents could be more efficient and effective than traditional large language models.
Definitely, I hope so, because I'm hearing a lot in the media right now about just how much energy those ChatGPT's farms take. So it sounds like going the brain route would be a nice way to go.
Indeed, yeah, absolutely. So it's going to be a very exciting decade ahead of us.
I'm excited. My last question for you here is about when we're talking about AIs developing their own consciousness. If we get to a point where we do encounter a super intelligence, or that develops in the course of things, how would it be possible to keep that consciousness morally aligned if they are super intelligent?
So I think that the real answer to this is that I don't think we can. So as I mentioned to you at the beginning, there are really two questions. Can you control a superintelligence, or can you align a superintelligence? I don't think we can control it. I think we can align it. Whether we can maintain that alignment is a very different question. But I guess philosophically, when I talk to people about this, I ask them, would you prefer to have a sort of zombie superintelligence, something that is not conscious, not aware, but you give it a goal and it will achieve its goal no matter what, right? Without really understanding its impact on humans or animals or our ecosystem, but it will overachieve its goal? Or do you want to have an intelligence that has the ability to be aware of itself and have maybe an appreciation of other conscious entities? And most people say that they'd prefer a conscious superintelligence.
Fair. We just hope that it takes the best of humanity into its next evolution.
Indeed. And I have to say as well, if we learn that it's not going to be possible to build safe conscious AIs, we'll be the first ones advocating that we need to really pause and think carefully about these technologies. So this isn't about a race to build consciousness. This is a race to understand consciousness and how to make sure that we are building it safely and responsibly.
Yeah, and understand is the really key word there, because if it's not just goal oriented, it's process oriented, then you can ask the real questions, which is not can we, but should we.
That's exactly right. Yeah.
Amazing. Well, this has been really interesting, Daniel. Thank you so much for sharing.
Thank you very much. Thank you.